So the previous slides were looking at a review of closed systems, closed and isolated systems, where all objects are in the system, nothing can enter or leave, total energy in the beginning equals total energy at the end. This is the first look that we have with open systems, where something from outside the system can come and interact with our system. Our system can interact with the surroundings. So that means energy can either enter our system or leave our system with an open system or a system that's not isolated. So that means that energy can be transferred into or out of our system. Now, it's worth pointing out that it's simply a different way to analyze a problem, right? And sometimes that seems like an unusual choice to make. But if you're a hockey player, you know that there are some teams that'll like to dump the puck into the corners and then try to see if you can get a shot on goal off of that, put the puck in the zone and see what you can do. There are other teams that like to control the puck and maintain possession and see what you can do with the ball, or pardon me, with the puck in your on your stick. Um, the same thing goes for really just about any sport, right? They're same thing in soccer. Some teams just like to kick it down, and once the ball's in the other team's zone, you hope that you can do something with it. Some teams like uh, possession, keep hold of the ball. If you're writing a story, if you like literature or art and drawing, there are different ways to try to approach any sort of creation of those things. Well, when we're studying a system of objects, there are different ways to perform that act. There are different ways we can analyze or study things. So we're simply looking at a different way to do things. And there are some benefits in different ways. So when we're looking at these positive work, uh, well, work, I guess, is one of the things we should bring up here, right? So work is if something outside of our system pushes on our system to cause a change. So if we go with like, this is my cup of tea, and if I say that my system is the cup of tea and the earth, there's gravitational energy in the cup of tea and the earth. Now, if I push up and it goes up, push up, goes up, I'm applying a force, I'm moving through a distance, I'm increasing the gravitational energy of my system. The push is up, the distance moved is up. I've done positive work, increasing the gravitational energy of the system. The height is now larger than it was. So that's when we talk about here, like object pushes left and it moves left, you're doing positive work, increasing the energy of the system. If you push the object up and the object moves up, you've increased the energy of the system. Sometimes saying that push up, move up sounds, to me, sorry, no offense, to me that sometimes sounds stupid, but it is possible to push up. Like right now, I'm pushing up on my mug, but I'm pushing up and allowing it to slowly go down. So it is possible to push up and go down as opposed to push up, go up. So if we're pushing and it's moving in the same direction, we're doing positive work on the object. And that means that we're increasing the energy of the system. So positive work increases the total energy of the system. We're going to go through and take a look at a system or an example where there's a cart spring track system, and we just did that with everything in our system. Now we're going to look at it with the spring outside of our system. So when we look at this problem with the spring outside of our system, good. Thought I had already moved that. Okay, so now we have the spring, the same exact setup as before. It's just that now the spring is outside of our system. We know the spring exists. We're just analyzing things in a slightly different way. So all of these things going on here. Um, when we're looking at all the stuff that we have here, we can say we're still starting off here. The spring is compressed. The cart is not moving. Velocity is zero. Speed is zero. Later on, the cart's up here moving and at a height. Now, when we're at this point, at this initial point, when we just did this with everything in our system, we said there was elastic energy in our system. Now, that's the subtle thing that we need to make sure we're focusing on, right? The spring is still compressed. There's still energy stored in the spring, but that spring not in our system. So we would not say that there's elastic energy here because, like our system schema shows, the spring is not in our system. So that elastic energy is stored someplace else. We don't have any elastic energy here, not in our system. The spring, not in our system. And I guess we can probably just open this final part up. Before we said that we had 4 units total of energy at the end. We're not changing that, right? We're not saying that anything different has happened. We're just trying to study this in a slightly different way. So before we said there were 4 bars of energy at the beginning and in the end. Uh, 2 gravitational, uh, 2 kinetic. That's still true, right? The Earth is still in our system. The cart is in our system. Um, the at position B, or at our final position, the cart is moving still. So there is a velocity between the cart, or of the cart. So there is a kinetic energy there. Um, the gravitational energy still exists because the cart has mass, the cart has height. Above this 0 point, there's a gravitational field that exists, and the Earth is in our system. So there's still 4 units of energy there. The thing that is different is now how we account for where these 4 units of energy came from. They came from the spring still, but now the spring is outside our system. So that's where we use this energy flow diagram. And in the first problem that we did this, we said, hey, those are the energy is the same in the beginning and in the end. So we're just going to put an equal sign in there. But now what we say is it's a little bit different. Now we're saying that the spring does work on the system. So I'm going to say work done by the spring. I'm just going to throw that in there. And so the spring does work, and the spring pushes the car that way, the car goes that way. So if the push is in the same direction as the motion, that's positive work. So I'm going to put a plus here. So that's positive work that increases the energy of our system. So this positive work that the spring does, the spring is outside of our system, increases the energy of our system. So I'm going to take this arrow and have it like point in to that circle, like we're adding energy into that circle. And jeepers, I hope, the blue square, I forgot to save a copy of it. So the spring does positive work to our system. And here, we'll go through and we'll take just a quick look to make sure we know where we're at. So without doing the work part here, without saying the spring does work, right now we're at 0 initial equals 2 kinetic and 2 gravitational energies final. That, 0 does not equal 4. So this is accounting for that energy that enters into our system from work done by the spring. So now if we end up with 4 units of energy, that all comes from the spring. So I need, or we need, a total of 4 of these buggers. So we just keep on throwing these pallies on here. Zoom, zoom. So now we have 4 units of work, positive work, done by our spring, adding energy to our system. So that arrow pointing into the circle is like we're adding energy into our system. That positive work done by the spring um, does not equal, beginning does not equal the final. So now we have 0 plus these 4 units of work done by the spring gives us our 4 units of energy in the end. So if we're going to go down here, we could say 0 units of energy in the beginning plus work done by the spring equals the energy kinetic final plus the energy gravitational final. And then I'm just going to make these subscripts to make them look more like notes and a little bit less sloppy. I forgot to put a big W there. So now we still have this equation. We're just now in our equation, we're accounting for the fact that we have work being done on these things. So uh, uh, the exact same result, we have 0 plus 4 equals 2 plus 2. It's just that now we have this 0 plus 4. We still have 4 equals 4. I mean, the math still works out, just a completely different way, a different way of analyzing the setup.